Hi gang, welcome to another video. Today what we're going to have a little look at, we're going to have a look at conservation of energy. Now in particular we're going to have a look at conservation of energy in relation to potential energy and kinetic energy. Okay, so this is abbreviation here. So we've got potential energy. So potential energy is the energy that's held within a body or a mass when it's at a specific height, and we'll come back to how we calculate this in a little bit later. And kinetic energy, we've got here, kinetic energy is the energy within a body as it's moving. It has kinetic energy. Okay, so we've got a clear difference between potential objects that are not moving and kinetic objects that are moving. Okay, now these two things are very closely linked by this conservation of energy theory, which states that energy cannot be created or destroyed, only transferred from one into another. Okay, now you can see here we've got a little image on the screen. Two potential energies turn into kinetic eventually, and then they both hit the deck. Okay, so let's have a little look. Now again, on your formula sheets you'll see potential energy and you'll have the formula for that, and then kinetic energy, you'll have the formula for that. So let's just work our way through here. Now we've got M in there, and M is equal to the mass. Alright, and we'll get our units for mass in there, which is in kilograms. We've got G, which is our gravitational constant, and the guys with a good memory will remember that value is 9.81, and that's meters per second. So in actual fact it's an acceleration value. And now I've got H, which is height, and the units for that is meters. Okay, so if we were to multiply all these three together, our units would look a bit wonky. So we'd have kilograms, meters per second, and then we'd have another meters. So that's quite a long set of units. So we actually simplify energy into the unit of the joule. Okay, so any time we're talking about energy, we're talking about joules as the value. So let's have a go through here. So we've got half, we've got M, we've got V squared. Alright, now this half's a constant, so it's always 0.5. Now really when we're doing these we should be thinking about putting a set of brackets on there, because this half the mass, these two are linked, and then we multiply it by velocity squared. So the M on there is again in kilograms, and then we've got velocity squared. So velocity, again, previous videos if you're missing that one, velocity and then squared there. Alright. So again, we've got a bit of an issue when it comes to the units. So if we always consider any energy values to be in joules, and that's why we use joules as the energy value for the value for energy, so that we can swap from one into another. Because if we were using these, that doesn't necessarily go into those units, so we have to be very careful that we're always using that joules value. So let's apply these. And what we'll do is we'll take an object that has potential energy, and then we'll see what happens when we let that object drop. It will generate kinetic energy, and we can actually apply these formulas to work out the velocity of this object as it hits the ground. So first thing we're going to do, we're going to go through the question and take the known values. So the first value that we've got is 80 grams. Now what's that going to look like? 80 grams. Now you remember from the previous slide we said that the mass is always in kilograms. So what we have to do is divide that by 1,000 to take it from grams to kilograms. So we'll have a value of 0.08 kilograms. Alright, we'll take a, again, constant, gravitational constant, 9.81 meters per second. And then we'll have our H, which is our height. Now our height is 300 millimeters. So again, remember from our previous page, our height was in meters, so we need to transfer that into meters. again we do that by dividing by 1000, so we'll end up with 0.3 meters. Okay, so we've got some values that we can start to have a little think about what we're going to do to solve this problem. So first thing I'm going to do, I'm going to take the formula for potential energy. So I've got an object, it's at height, it's at this point here, it drops, it then has a velocity. So I'm going to find out what the potential energy is in that object. So I've got mgh, so I've got P equals 0.08 times 9.81 times 0.3. I'll give you guys a minute, you can stick that in your calculator. And we'll get a potential energy of 0.23544 joules. Okay, now that's not a massive number, but the calculator never lies. So what we're then going to do, I'll pop that back up. We're going to transfer this potential energy into kinetic energy. So what we're actually saying here is 0.23544 is equal to half m v squared. Alright, so again, energy cannot be created or destroyed, only transferred from one into another. So what we're going to do, we're going to rearrange this formula for V. So what's that going to look like? So first thing, we'll take this half the mass and we'll divide both sides by that. So we're going to divide this by half the mass, which is 0.08. Okay, so we'll have here, and that'll equal V squared because that cancels. And again, if you've missed any of the previous videos about rearranging, make sure you go back and watch those. That might become a bit clearer what's going on when we're moving these formulas around. So we've got 0.23544 divided by 0.5 times 0.08 equals V squared. Now I'm going to square root both sides of this. So I'm going to end up cancelling the V, so we'll have V is equal to the square root of 0.23544 divided by half the mass. So velocity, and again I'll let you stick that in your calculator. So the velocity of this object as it hits the ground is 2.43 meters per second. I really need to sort this pen out, don't I? It's putting all these lines on. It's getting a bit annoying. I'll pop those numbers back on there that we've missed and that we've taken off. So we've got 2.43. So what we've got happening here is we've got an object, it's got potential energy, we'll let that object go and we know its velocity as it hits the ground simply by applying these two basic formulas. So next slide, there's actually some question, an exam style question on there where we've got an object, it's at a specific height, it starts to travel down to get to a different height, and we're going to calculate potential energy and its velocity as it hits the ground. Now an expansion on that one, something for you to have a little think about. How do we reduce friction within engineering systems? And get someone to get your teeth into. Now again, you can send me your answers to this question through Canvas, or you can upload them, email me, whatever it takes. We can have a little go at that one, and there's also further examples in your workbook that you can have a little look at. But just to reiterate, we've got our potential and kinetic energy, we've got our formulas, and we've got an example of where we're transferring from one type of energy into another and working at some unknown values. Okay, so there's plenty of practice ones you can have a go at. Hopefully this finds you in good health, and as always, if you need any help, just let me know. But once again, thanks for watching and good luck. Bye bye.